Welcome back, everyone. So, in our first video, we talked about like what is machine learning and the three types of machine learning, that is supervised, unsupervised, and the reinforcement learning. So, in this session, let's explore the actual workflow, how raw data is transformed step by step into useful predictions. So, So initially in data pre-processing, uh, every machine learning project, it always begins with data. You always have a data set, like either in a spreadsheet or anything like images or an X-ray or a numbers, text, audio, anything like that. The one which you are seeing over here in the numbers, it may be anything depending on the rating numbers or anything like that. The images, it could be apples or orange images or an X-ray image which doctor differentiates about a patient. And a text could be something like a Google review or any kind of reviews, depending on. And so data is the foundation. So and high quality data, it's always a better learning. That's why we do the data pre-processing, because data is the key foundation. It's the basic thing, and if the foundation is weak, the whole project will suffer. That's why we will focus on the data here. So what is data pre-processing? uh, the real reason why we do data pre-processing before we train the model is because we have to prepare that data. One of the analogy is on the left side, as you can see, it's just like before cooking, you prepare the ingredients and then you actually start cooking. Because always the raw data is not clean, it's always messy. So if we use the as is model, the model will truly struggle. So in processing, in pre-processing, what we mainly do is we clean the missing values, normalize the features, and sometimes create new features. We'll talk more about feature scaling in the future slides. Think of this as preparing, as I mentioned, like anything before you prepare, like even a cooking or something, you actually arrange the ingredients, and that's why. So the third step is, training the data. To train the data, we have to split the data into two parts. One is the training data, and another one is testing. Usually, training data is 80% and testing is 20%, but it depends on the scenario. Sometimes they also add a validation. And training is used, a set is used to learn the patterns. Like for example, uh, the algorithm, it studies the relationship between inputs and outputs. In a future example, we are going to look for an example like an apple, right? If it's an image, you're going to load the apple images. You the image will understand the pattern of the image, and same thing for oranges. And when you show it, it will differentiate which is apples and which is oranges. Same way between cats and dogs, which we talked about. And based on this, it builds a model, essentially like a set of rules it can use to make predictions. Training is just like a study phase where a student learns initially. So it's just a basic, like a training part. The keyword training itself says what it is doing. And after that, the just training is not enough. We need to check if the model is actually truly learning or not. What I mean is that you need to check the accuracy of the model. You may train the model, and yeah, as previously I said, that if you load the images of apples and oranges, and when you show an orange, the model may say that this is an apple. Now, you may have trained, but still the output is inaccurate. And for orange, it is identifying as an apple, which is not good. So that's why, we compare our predictions with the actual results. Like, you compare apple and whatever it is with the actual results, and measure its accuracy, precision, and recall, as you can see here. This evaluation is done mainly because these metrics show not only how often the model is right, but it also shows that how reliable it is in different situations. It's just like what can I say, like grading a student's practice exam. Now the another step, the last step is, once the model is trained and evaluated, the model is actually ready to use. Now this is where machine learning actually becomes functional. Like a model can predict, like once if you give the number of house, based on its land, square feet, the area, locality, and everything, it predicts the price. And same way, in an email spam, like depending on if the email is a spam or not, you give a specific pattern, like hidden pattern, especially when we talked about the unsupervised learning in our previous slides. It would identify through hidden patterns and then detect if the email is a spam or a not and categorize it. Same way for the images, if it is apples or orange or a cat or a dog, whatever it is. And this is the exciting stage, where actually your theory becomes a reality. Just to recap, for data pre-processing, these are the things we need to do. First, we need to do a data collection. You collect the data for what you are analyzing. Then you pre-process. Is it pre-processing? It's just like preparing ingredients before cooking. You cleanse the data, arrange it, and you train the data. You don't train the entire data. You just train like a percentage of it. It's a maximum percentage, usually 70 or 80%. And once that training is done, you test that and evaluate it with the remaining 20%. Then finally we make the prediction. And this is how we split the data into training, validation, and test data sets. Now let's zoom into the actual process, like training, testing, and validation, and test data sets. Usually, whenever in machine learning they just teach about training and test data sets. In this scenario, we are going to look for validation also. It's just a small extra step. Some machine learning algorithms use validation and some don't. We are just going to look into validation just to for learning purposes. So once, as you can see here, this is where a complete data set is given. This is about the simple example which shows that the students, the number of hours which they have studied, like the 13 students, and the percentage of attendance, did they attend like 95%, and the practice tests which they took before giving an exam. And the label is an output, the feature is an input, and the label is an output. As you can see on the top over here, the feature is the input and label is the output. So this is the actual data set. And as an example, we are loading this model learns. For example, if he has, like on the first one, he studied 10 hours, he attended 95% of the class, and he took 4 practice tests, he passed. But there was another student below that, he just took no, he just studied 2 hours, he attended just 60%, and he took like 0 practice tests and he failed. So that's like a basic data set which we are feeding. And once we do that, next, we are going to look for the training data. From the previous data which you see, out of the 13 students, we are going to take a few numbers, probably a 70% of the data from that, and we are going to load the actual answers. Like if he studied 10 hours, attended 95% of the class, and practiced 4 tests, and he passed, same way we'll load. We are actually training the model with 70% of our existing data. Uh, I'll just give an analogy here. It's just like studying the textbook and past questions, and that's it. So once we train, the model learns from what we have provided with the existing 70% of the data. And other one is like a validation data. The validation is just like an extra check. Not every thing has to be validated. One thing I can give an example of validation is whenever you're deploying something, you actually validate, right? So same way for validation, what you do over here is you actually do an extra check. So for example, the same data set, for example, the above data, the training data, you loaded with section A section students. Now this is like a B section students, and it depends on for 2 students we are just validating here. This isn't used to teach it directly, it's just to check during training. If the model makes mistakes here, we adjust and fine tune it. Validation is just like a mock test, a way to see like how a student is before the real exam. Now this is a final data set. So finally 20% is set for the testing. The model has never seen the label portion over here. We just give the hours studied, attendance, and practice tests, but we don't give the label over here. At the end, we use it to see how well the model performs on completely unseen examples. Like what happens over here in the test set, this is the final exam of the model. If it performs well, we truly know that it has worked in the real world. So how we actually compare is, you give this data set like he studied 9 hours, attended 95% and gave 4 practice tests. If it the data might give us pass. And same thing like the second one also, he studied 2 hours, attended 65% and attended 1 practice test, it gave fail. But sometimes there is a chance the model might confuse and give it as a pass. And the model might give it as a pass, but the real result will be fail. And that means your model is not accurate. That this is how you actually compare your test data with the existing answers, and you provide output. So if we recap, what we did was we used training 70%. More training is model, making the model learn patterns. Validation is just fine tuning the model like a mock exam, what I said. And the third one is the test 20%, just evaluate the performance. And the training, so the analogy is what I'm trying to do is just trying to make an association for the memory to understand. Like training is like studying, validation is like mock test, and the actual final test is like the final exam. So I hope you have understood what is a test and a training data set. Hope this helps. Thank you.